Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes. So today we have minimum operations to make array value equals to k. So on the given questions, they have given an integer array nums where and they have given an integer k. Now an integer h is called valid if all the values in the array that are strictly greater than h are identical. Right? So for example, if nums is 10, 8, 10, a valid integer is h equals to 9 because all nums of I greater than 9 are equals to 10, but 5 is not a valid integer because what they have asked for, they basically looking for an integer h which is called valid if all the values in the array that are strictly greater than h are identical. So that means there can be n number of elements in the array which are greater than h, but all should be equals. So let's suppose you choose your h as a 2, and let's suppose you have 3 elements of 5 and 2 elements of 3. So let's suppose you have 2, 3 and 5 elements of 5. So how many group of elements? There are 2 group of elements. So then the choose of h is not valid. So when you are choosing an h, then there should be only one category of strictly greater than elements. So there should be only one group of strictly greater than elements. So I think that is the most tricky parts of this particular question. So I will explain this to a one note because that particular lines is actually they make it a little bit on the complex side. So I will explain this line to you guys. So what they have so what basically they basically try to say here, let's suppose we have an elements array with a b c d e f, right? Now you choose an age value, and this age choose is called to be valid when there are, let's suppose c is greater than your age, right? So there can be and d, let's suppose, is also greater than your age, and let's suppose your e is also greater than your is also greater than your age. Then c, d, e, then your c, your d and e should be identical. So the condition should be c equals to d equals to e. So c, d, e should be equals. Then only this h is going to be valid. This h is going to be valid. So on this, are you guys getting an intuition? So you can choose an element. So a valid age should be just smaller than the largest value in nums. That's the for sure. Because if you choose an age and let's suppose age is smaller than the largest value, let's suppose it is the second largest, let's suppose it is the third largest. The age which you choose, it is third largest. So let's suppose e is your first largest, so age is smaller than for it's sure, and let's suppose there is a value f and age is smaller than f also. Then age is only valid if your e equals to f. But if there are two elements, let's suppose ef, or let's suppose there are n elements, x, y, z, there can be n elements which are greater than my age, there can be n elements, but on that case all of them should be identical. If that is so, then this h choose is valid, and if it is not, then that is not. So let's suppose if it is not, then we have to choose what is the largest among all of them. Right? Let's suppose z is the largest among all of them. Then we can choose our age, which is just smaller than my z. So my age can be, on that case, z minus 1. So that can be my age. So on that case, there can be only one element. There is only one element in the entire array which is greater than my age. And what is it? It is z. Now for z, For z it has multiple occurrences. There can be n number of z's on my nums array, but all are identical. All the z's are identical for which I have choose my age. I think you guys got the gist. What actually by this line they are basically trying to say. So if not, then please go to this particular OneNote explanations. Then you will definitely get this gist. And if until you get this gist, then the next portions is not going to make any sense to you. So please go to this OneNote sections one more times, a couple of more times if you are not going to get the gist on the very first one. Yeah. So that's the things they have basically tried to say on these couple of lines. Now they are basically asked, you are allowed to perform the following operations in nums. Now what you can do, select an integer age that is valid of the current value of nums. We already understand what is the valid value of age. We know that's for sure. That can be at least the largest value. What is the present in my age, in my nums, that should be at least one smaller. It can be more than one smaller, but at least one smaller. And for each index of I where nums of I is greater than age, we can set nums of I to age. And for the indexes where my nums of I is greater than my age, we can set it to age. Whatever the age we have choose. So I think these two lines is very, very simple. If you are able to understand the explanations of this line, which we just did in the OneNote, then these two lines are very simple. And after that, return the minimum number of operations required to make the every elements of nums equals to k. So our end goal is to we have to make all the elements in the nums to the k value they have given to us. And how you can make, you are allowed to perform these operations as many times as you want, but they are looking for the minimum number of operations. They are looking for the minimum number of operations. And if it is impossible to make all the elements equals to k, then on that case you can return a -1. Then on that case you can return a -1 for this particular test. So the question is tagged as an easy. So this is because the constant, the sole reason is constant, and nums of I is also very small, k is also very small. But if it is a easy level question, then please be ready for a follow-up. If you are going to in the interview of a top product based company, then please be ready for a follow-up for sure. And don't try to for every easy question, don't try to write on the big of n square type of complexity when you are in practicing. Try to make the most optimal submissions on the Leetcode. Try to make it in big of n. Try to think on some big of n type of complexity, and try to give yourself as a challenge. If it is the same questions can be tagged as a medium. If you can solve it on a big of n complexity, then the same questions can come as a medium level question. So that's the follow up actually on the interview we'll going to face. So try to solve on a big of n complexity. If they are tagged something on a very, very low constant as a easy, then try to give yourself as a challenge to solve it as a medium difficulty by solving it a big of n complexity. So exactly that we will do. We are not going to write the brute code. We are not going to write the better code. We will directly try to solve it on a optimal solutions of big of n kind of solutions, because we know you can perform the operations you can choose any age and you can try perform the operations, and after that you can reduce your age. The brute can be like an extreme brute can be big of n cube, also going to be accepted because based on the constraint, but we will not going to be jump on that. We will directly solve the optimal solution. So tell me guys, what is the -1 conditions? What is the -1 conditions when the answer cannot be formed, when the answer cannot be formed? So here you can see they basically asked to make every elements to 2, but it is impossible to make all the values equals to 2. How? On which cases it is we are not able to make every value equals to k. Now let's go to our OneNote. So what operations we are doing actually? If you can focus on what operations we are doing actually. So let's suppose we have again our array ready, A, B, C, D, E, right? Let's suppose we have an array ready. So what actually we are doing in our operations? On our operations, we are choosing an age, and whatever the values. So I am thinking like you are able to choose your age optimally. So what is the optimal conditions? We just explained. There should be at least one group of there should be single group of bigger elements. If there are 4 bigger elements, all 4 are which are greater than my age, all 4 should be identical. All 4 should be identical. They should be equal. So that's we just explained. So let's suppose we choose an operations. We choose on one operation we choose an age. We choose an age and we try to make whoever all are bigger than me. We will try to make everyone. Let's suppose there are D is bigger, E is bigger, and let's suppose my D and E should not let's suppose it is bound to be equal. It should be bound to equal. On that case, we are choosing our age should be optimally. And what we are doing? We are making both D and E is equals to k is equals to h, sorry, is equals to h on one operation. So whatever the value d and d which are greater than my h, we are making b equals to e equals to h. So we are reducing some portions, right? So for every elements, by these operations, by the operations they are allowing, we have the liberty to reduce some elements, Do we have the liberty to increase some elements? So can we increase some, what is the value of a particular element is? Do we have the liberty to increase any value? Do we so with the operations they have given? No, that is not allowed. So I think you got the -1 case. So if the smallest elements, so I know for every elements of my array, for every elements in my array, I have to make them equals to k. And I know in operations I can reduce them. What is permitted? I can reduce them. But let's suppose this a is altogether smaller than my k. Then can I make them is k? By any chance can I make them k? No boy, you can't make them is equals to k, because in operations you have the liberty to reduce the number. You don't have the liberty to increase. So if we have at least one element which is already lesser than my k, so can I say on that case my answer is altogether -1? Yes. So that is the case when we are not able to form our answer. So exactly that is the case when we are not able to form our answer. And for all other cases, we should have, because if that is not a -1, then can I say if that is an else case, like all the elements a, b, c, d, e, whoever present in my array is greater than or equals to my k, If there are at least one smaller element which is less than my k, then we are not able, then our answer is -1. So all the elements which are present in my array, should be at least greater than equals to k. Should be at least greater than equals to k. Now what is the minimum operations, man? Can you tell me? I think it's a little bit complex, but if you make your brain a little bit more stressed, then you should obviously figure out. So if you can think in one operations, let's suppose it is also e, and let's suppose e is the largest elements in my array. So we have two e's. So one is this e, another is this e, and we choose an h, right? What is the h we can choose? And let's suppose our array is following this principle: a, b, and then d, then e, right? And sorry, I wrote it completely reverse. So a, b, then d, then e. So let's suppose e is the largest. So on one operations, what you can do? You can choose this couple of e's. You can choose your h. Equals to d. Then on that case, by these rules, these e's are going to be picked. These e's are going to be greater than my h. And I will make them equals to d. So after these operations, my array would hold a, b, and all are transformed to d. After one operations, right? All are transformed to d only. Now on next operations, I know my array is following these principles. I can choose b as my h. What are then bigger? These trees are my bigger, and I will end up making all these d's are equals to a, or is h, and we choose our h is equals to b. So after these operations, my array will hold all are equals to b, except the a, and on very last case, I will choose my h as an a, and I know these all are bigger, and after these operations, I will have everyone is equals to a. Agree. So that is the most optimal way to perform the operations. So how many operations, if they have asked for k equals to a, so how many operations we are performing? So the operations is nothing but how many distinct elements. Can you guys point out how many so on our initial array, how many distinct elements we have? We have one distinct here, b's are distinct, e's are distinct, d is distinct. So this is repeated. So we have four distinct elements. Now Now, so to make all of them equals, we have to perform the operations at least the four. So the number of distinct elements we have at, so that many number of times we have to perform the operations to make everyone's to equals to k, to everyone's to equals to at least the smaller one, at least the smaller one. So you can see like one operations, two operations, and on third operations we are make everyone's to equals to a, and let's suppose our k is equals to a, or k is equals to a. So how many distinct elements we have at is greater than my k. We have d is greater, e is greater, d is greater. We have, let's suppose we have these three elements which are greater. So we just have to make these three is equals to a, and we know our k is equals to a, so we don't have to perform further operations. But let's suppose they have asked for k less than a, then after making everyone to be equals to a, we have to perform another operations. On that case my k is equals to h, and after that I will be make everyone's to be equals to k, right? But on that case, as k equals to a, then on these particular steps we can stop performing the operations. So what is the operations actually? So the number of operations, can I say is nothing but the number of distinct elements which are greater than, not equals to, which should be greater than my k, which are greater than my k. So if my k is equals to a, then I know I will stop until to make everyone's to be a, that is the smallest one. But k is more smaller, then I have to, after making everyone to a, then after that also I have to reduce. So it is nothing but the number of distinct elements which are greater than my k, that many number of operations we have to perform. Now can we solve it in big of n? Then can we solve it in big of n? Definitely yes. So now let's quickly jump on the code itself. So we have initialized our default dict because we know we have to check if that is a repeated elements, then on that case we will update our frequency map. We will not going to create another entry. We will just update our frequency map. We are looking for distinct. So when we are looking something like distinct, so there should be some frequency map, or can be set, anything you can use set also, but we need, for distinct we need a frequency map or set for sure. So I am using a frequency map for my uses, and I am following a count variables. I will explain what is the use case for it. So I am iterating just a single for loop, you guys can see. So that is exactly big of n. So now I know what is the -1 case, what is the ineligible case. If at any elements if we encountered at any elements which is lesser than my k altogether, then on that case we know we have the liberty to increase, but sorry, we have the liberty to decrease. But we have an elements in the array which is already smaller than my k, and by decreasing operations, can I make them equals to k? No. So on that case we can return the -1. Exact same things that I just explained on the one. Exact same things. If I encounter any elements which are less than my k altogether, then on that case we are not able to build our answer. And if that is not so, and it is the very first occurrence of this number, right? It is the very first occurrence of this number. So then on that case, what we are looking for? We are looking for the number of elements which are greater than my k. So that is the number of operations, right? Who are greater than my k. If that equals, for that we are not going to perform any operations. If k is equals to my a, so on that case you saw, right? We are making everyone to a, but after a we are not decreased. After a we are not decreased. So what we are looking for? We are looking for the number of distinct elements which are greater than my k. So how we can know if the current element is the distinct? So this is not a repeated, which I previously not seen. So this check will make sure that. So on my default dictionary there is no entry for this particular elements. So that is the elements, is the distinct elements. You are looking for it very first times, and this element is also greater than your k. Then what are you waiting for, man? You can increase your counter, you can increase your operations count, for 0, and add it to your dictionary, add it to your default dictionary, because on next time you are not considering is a distinct. You have already considered as a distinct. You have already considered its first occurrence. So on very next, you are not considering its next occurrences. And finally, we are returning our count. So yes, guys, this question is as simple as that. And we will quickly discuss now the time complexity of this. So the time complexity of this particular questions, we are not doing anything. So we are just iterating to our arrays a single time, that is of big of n for sure. And what is the space? We are using a frequency map. So that is going to be taking a big of n for sure. And apart from that, we are playing with the variable solving. So that is the most optimal time on space complexity for this particular questions. And I'm pretty sure my submissions is like most 100% faster of all the Leetcode submissions. So that is the most optimal time and space complexity submissions you can find on Leetcode. Yeah, so that's it, guys. That's it for this particular questions and particular question solutions. And if you guys are able to understand till this point, I guess you guys is already aware which you have to do. So please do subscribe to our channel, and please turn on the notifications so that when we are going live to our next video. So bye guys, let's meet tomorrow with another beautiful video. Bye bye.